All right. So we're discussing the backfilling of the environment ID column on the deployments merge request table. It's GitLab merge request 27219. And some concerns there about how we're sort of going to do that in a way that is efficient enough and doesn't require downtime, etc. The current implementation uses a temporary table that is filled up, and then that data, I believe, is inserted into the old table. Then there were some proposals to use different approach, like a temporary ID column and some PostgreSQL specific approaches. So we want to discuss sort of the pros and cons of those and see if we can kind of make things work. Let's see. So we have the temporary ID one. I think we sort of, I guess I at least realized it wasn't going to be as easy as just add the column, use it, off we go, because our code for updating, adding columns concurrently, I believe doesn't support expressions as the default value. So only literal values.
Yeah, or maybe we can use an array. It should support an array node. So if we can write an array node that do the sequence increase, it will take it.
Yeah, that is one approach. But then
but telling Rails to ignore that column during the deployment is more concerning than.
Yeah, basically. And then the alternative was to use the PostgreSQL internal row and page IDs. Basically, for those watching, every row in PostgreSQL has a sort of internal ID. It's a tuple of, I believe, the page number and the sort of row number on that page that the row is on. So it's kind of like a composite primary key, basically. The benefit there is you can fetch rows using those IDs fairly quickly, kind of like a primary key. Downside there is if you use a where expression, I believe we use like greater or equal, or lower or equal, it has to do a sequence scan on the table. So it generally only works if you want to, I believe, get the like the rows with like the literal value, basically. We sort of experimented there, but it's not entirely clear, I think, how exactly we were going to use that and if it works.
I was looking at your answer, so I realized that you replied to my comments. So there's this point when I was asking about the why you say that there are 2049 TIDs, and looking at the answer that you gave me, my understanding is that this is the number of row within a page. So the point is, how do we get the number of pages, for instance?
Right. Yeah. So it was. I think it's. The number of pages 2049. Let me see.
Because the first element of the tuple is the page number, and the second one is the row number. And this code that you did is incrementing the second value.
Right.
So it sticks to page 0 and enumerates all the elements.
Yeah. So let me see. I was gonna open up a connection to production. Just want to make sure it's in read-only mode. But I need a transaction for that. Whatever. Let me share my screen. Share. Then I have to make sure it's the right one. This one, I think it is. Yeah, let me increase the font size. I think then it still shares a subsize of the window. Let me try that again. There you go. So the query that I ran, where did it go? Yeah, so this just counts the number of pages, I suppose, which is 2049. If we just...
I'm muted. I say this is the number of rows, not the number of pages. 0 is the page number.
Oh, the number of rows per page. Yeah, good point. Oh yeah. So we have, let me write this down. Let's see. Right, so 249 rows per page. Yeah, that's a good point. How we?
Yeah, I think because what I understood reading the original document that you linked is that basically you can have holes in this sequence. Because
right.
if you delete something, that it just get deleted. So in that case, the row will have nothing. So if you select the whole table and you also ask for the CTID column, which is this one, you would just see that there are holes in there. But I don't know if it's worth to just say there are up to 2049, whatever, rows per page. So we count the whole table, we divide by the number of, and say, okay, we have up to that page plus one. That's it, because then we expect the final query just to find nothing or things like that.
Yeah, let me see, because if I just a select count, it times out, but we can get an estimate. If you just select star from deployment, merge requests. So it estimates, yeah, 1.17 million rows. That's probably a bit more than what there actually is. 2049 rows per page. So then we have 8,500 basically pages. So what we would then have to do is basically from 0 to, let's say, 9,000, just to be sure. You have to iterate, and then you have to get all the rows on that page. But
yeah, but then this means that we have to issue 7 million update. Because if we could start from say collecting everything that matches to environment ID 1, for instance, and then we can use a subselect, which we can. Oh, well, we can. Yes, we can, because we can do join and take the CTID out of it.
Right. Yeah, so I think in terms of just selects, what you need to do, basically we start with 0,1, I guess, or 0,0, I'm not sure if it's one index based. Then you basically increment that to 2049, and then you start over, you start with 1,0, 1,1, etc. And you basically keep doing that. So I think what you could do is, in theory, you given a page number, you fetch all the rows, which is up to 2049. You just basically load those into memory. I think the way you do that is deployment merge requests. Right. It's not auto completing. That's a bit annoying. Where seated in what is this? 0,0. Let's just give some 0,1. Let's do that. Let's see if that works. Deployment. Oh, deployment merge request. That's fine. Right. We should also do seated. Yeah, so we end up basically with a giant yeah, basically an in. Let's see how that performs. Explain, analyze. So that's still a tit scan, CTIT scan, whatever. Yeah, so wherein would then contain 2049 values for every page. And I think what you can then do is, given those rows, I guess you would fetch the unique deployment IDs and then do a update for every unique deployment ID to set the environment ID. So you get something like, let's say, select distinct deployment ID. and then you do something like, update deployment merge request where deployment ID in set environment ID is X. So it is going to be quite a bit of updates.
So what you're suggesting here is just to use the CTID to partition the fetched data, but
yeah,
not to update in place, basically. So you're not using update every row that has this CTID with this final environment ID because you selected it before.
Right. Let me pop open Vim, then I can type the query there without accidentally executing it. Where's my font size? Oh, let's use the terminal then. And Vim, make that a bit bigger. It's readable. That can go away. Then I'll share my screen again. Just do the whole thing. There you go. Right, so here on the right we have Vim, let's say SQL. So we basically end up at some point like update deployment merge requests set environment ID equals X, where deployment ID in select. Boy, okay, hold on. So what I think I usually do something like select distinct deployment ID from deployment merge request where CTID in 0,0, 0,1, oops, etc. Because the subquery will at most, I guess, return 2049 rows, but due to the distinct, most cases will probably be a bit lower. And then we update it. The maybe additional way you say, and environment ID is null or something like that. Maybe here too, and environment ID is null, and that one is not needed.
Okay, this will fail because we are deleting duplicated, right? So this will create duplicates.
Will it?
And this the whole reason why we are doing this.
Oh yeah,
Get rid of
that's
duplicates.
True. So we have to remove the duplicates first, I guess.
Yeah.
But I think removing the duplicates itself is a little easier because what you essentially can do is you can do select count and then group by, I guess, the combination of, or by merge request ID, or either way, whatever the sort of composite is. And then you get the rows where the count is greater than 1, and then you just remove. So you get where the count is greater than 1. Then again, you have to fetch those rows where the duplicate ones, and you do I guess a delete with a subselect or something, where you basically limit it so that you only remove all but one row. From the top of my head, that's something like delete from deployment merge request, where let's say by what column are they sort of duplicate? Is it like multiple rows with the same merge request ID but different deployment IDs?
Yeah, that's it. Because you can, we had
but that's
the same merge request.
Possible. Because you can have a merge request deployed to staging and production. There will be 2 different deployment IDs.
Yeah, and this is fine. But the other one is that when you have, before we introduced the environment ID key, we had same merge request to 2 different deployments targeting the same environment.
Oh, right. Okay. So we need to join and then group by that. So it's something like the delete from, let's say we get to the duplicates first. So we do.
No, because what I'm thinking is that if we end up doing the join,
right,
which is we will, then we can do this for the update and delete. Right. So we the query that do the update just do the select join, and we can paginate over environment, without doing the CTID thing.
All right, yeah, we could
Then we do update things that have those CTID. So the subqueries.
Oh yeah, right. Oh boy.
Yeah,
It's
do you
starting to
understand
get.
why I did the other approach? Because I
Yeah.
started messing with this. Okay, this is
Yeah, I think it's one of the cases where we have to really break it down into, like, let's say, 10 separate queries first, and then see how we can sort of stitch those together. It's just trying to think of what sort of the final query is going to look like. My head already explodes. Let's do this. How can we best test this without blowing stuff up? I will just start a Rails console. Now there's probably some production engineers looking at this go like, oh no, production. Just typing these tuples from the CTIDs is a little annoying. But yeah, so I get we get something like yeah, we select the distinct or just all rows. Okay. Boy. Okay, so we have two things. We need to get rid of these duplicates, which means we have multiple rows where the merge request ID is the same, the deployment ID is different, but the environments they point to is the same.
yeah.
So in other words, deployment A and B may point to environment A, and if there's two occurrences of a merge request, we only want one. Normally, if you have a primary key, we can do something like a delete from blah, where ID is not maximum something.
Yeah.
We don't have, so we have to delete it by the CTIDs, I guess. Oh boy. Let's see. So let's get the. So we have 2049 pages. We do pages 249. And then we had how many rows do we estimate? Let's say 7,000 per page. 7,000 just to be safe. Sorry, I think it was 9,000. So it's 8,600. So.
Yeah. Right.
And then it is TIDs. Shoot. So the page is 0 to.
Sounds like 0 up to 9,000 pages.
No, so the page is 0 to 249, and then the row, I guess, is 0 to the what is it, 9,000. So we need to generate a permutation of that. Let's just start with row 0. So it is 0 to 9,000. Oops, we map that. I, let me get 0, comma, I. Oops, it's recording. My typing skills drop drastically. There you go. And then we do deployment merge request, where was it CTID in TIDs 226. Let's just get the first just all of them. Rows. Right, so then we have a bunch of them. Rows first, let's say first 10. Let's make this a bit bigger. Oh, it's because it's objects. Let me map that so it's a little more readable. Was it attributes?
I'm thinking if our estimate of the number of pages is correct, considering that the first page gave you 200 rows
Right.
instead of 2,000. So because
Yeah, so
when you delete the environment, we cascade delete things back. So probably we
Right.
have more pages.
Well, so the pages I think is correct. It's just because the number of holes. So we have here a page probably of 226 rows. But then there might be other pages with more rows, I guess. Let me see if we can find a case like that. Let's just say we grab page 5 or whatever. Then we count the number 226. Interesting. So let's say a 2000 page number. 226. Huh. Interesting. So it keeps producing that. I wonder if then the row IDs are different.
Yeah, this
Let's
is
see.
weird.
Let's go back to the database console. Let me see.
I think we can take the last deployment and getting, so from the deployment we get the merge request deployment,
Right.
and then we have the CTID there, and we see which.
Let me get my browser. Oh no, that's Zoom. So if we get a deployment ID, environments. Then we do need one where there's actual merge requests associated with it. Let's just get staging. That probably has some merge requests. So we do, where's my SSH? There we go. Select star from deployments where project ID X and ID. Then the project ID. There we go. There. Why is that taking so long? The deployments. Is that column indexed? Project ID is indexed. ID is indexed. Of course, ID is also indexed. That's interesting. Explain why is that taking so long then? Huh. Project ID. I guess we only need the ID. Okay, I don't know. Maybe weird network error or something. Anyway, so select count star from the deployment merge request where deployment ID. So, damn it, that deployment does not have any merge requests. It's basically what I think is if we can get a couple of recent deployment rows, we can see what the CTIDs are for those rows, and we can
this
sort of
was
see
my
what
suggestion.
the distribution is. I guess what we can just do is select CTID deployment ID from deployment merge requests where.
So we can do the deployment ID. We can sort by deployment ID and take the last.
Yeah, that's basically what I was thinking.
It's incrementing, so the biggest number.
Order by ID descending limit 10, I guess. Deployment ID, where deployment ID. Right. What? Select ID from deployments where project ID is 27. Why is that subquery returning any rows? Let's see, 10. So that is returning deployments. Deployment ID from deployment merge request with deployment ID. It's a bit bizarre.
Yeah.
It's maybe returning deployments for different environments. Ugh. So what we do is select ID name from environments where project ID that's and name equals
review application. That's why we every merge request prepares view application and we don't track it.
Let's see. So what we do then is select deploy or rep and environment ID equals. There we go.
Okay.
Okay, yeah, that looks a little different, those IDs. 78,115.
Not 9,000.
No. Yeah, but that's weird because the first column is the page number, right?
Yeah.
So then that other query that just permuted the page numbers, that one I guess was plain wrong? Or is that I guess that might be the value for the second column.
No, I mean that we assume that because of the page can fit up to 2049 rows, every page has 2049 rows. But when you delete something, you create a hole in the page.
Boy. Jesus. So I guess what we need to know then is basically the maximum value for both these columns. I guess I selected a few too many rows for the page nation. Come on. Let me just limit this a bit. Limit 100. Yeah, see, that second column never really goes above 200 by the looks of it, but that might just be coincidence. Yeah, I think at this point maybe we should have Andreas take a look. Maybe he has some suggestions, because this is something where I basically need to sit for like 2 or 3 hours and look at the data and see, okay,
Yeah, right.
Can we actually do something with this? I think there might be a solution here. But yeah, it's going to be tricky. The other option that I saw is that we can use cursors, which is basically stateful pagination on the database side, but you have to use a transaction for that, because they are scoped to a transaction. I think in that case, what you could do is you basically start with no transaction. You start one, you get a limited number of rows, let's say 5,000, whatever. Do your updates and then sort of move on. But I'm not sure how you would then sort of figure out what sort of offset to use for the next transaction.
Can we go for a while through why adding to a temporary table and destroying it at the end of the migration is not a viable solution here? Because this is not a busy table. We just populate this asynchronously when our deployment happens. So
it is, and it's an entirely valid solution to basically duplicate this table. There's some SQL statements we can actually use where you can create a copy of the table, including the indexes and everything. You fill it up and then basically you rename it. The issue then is you have to keep those tables in sync. So you have to start using triggers to make sure that.
Yeah, but this is why I didn't copy it, but I just created it from scratch. Because because with a simple join, I can get the environment ID from the original query.
Right.
So I can fill data from source table to the new one.
Right.
And with onConflict discard, I can ask basically the second table to take care of dealing with duplicates.
Yeah, so that is very much a viable solution. The tricky thing is there when you swap the tables, you can, I guess, insert the data. Well, you have to remove the old data somehow. So
yeah, I do remove and put it back. So I'm not just replacing the table. I'm just copying the incomplete data in a complete form in the new one. So the duplicates will be deleted in this insert operation. In the meantime, the new code is already running because we deployed it. And also it's a post-deployment migration. So the new code is already running. So every new deployment will get the full tuple with also the environment ID in the system. And so at that point in time, I can delete everything that has environment ID set to null because there's no code running anywhere that is still creating stuff with environment ID null. So I'm missing data at this moment in time. So there's a tiny window of time where basically the production data is on a temporary table and we removed it from the official table, which means that if you query the APIs, if you just go through the merge page, you will see incomplete data. And then we fill it back. When we fill it back, we will handle duplicate deletion again. Because if in the it should not happen, but if in the meantime something had the same environment ID, we will basically remove it.
Yeah, so that could work. There's some issue there if you do the delete of the old data and then insert the new data in two separate transactions. There's going to be a short period of time where merge requests won't be associated with deployments because we basically deleted them, but we haven't copied them over yet. That is effective. It's not data loss. It's like temporary data unavailability, I guess, but it's annoying. The issue there is if you stuff that in a transaction, I think that transaction is going to time out. And it will acquire a lock on the rows to delete while doing it. Because basically when you copy the data from the new table or that temporary table to this physical one, it also has to update all the indexes and everything. And that's going to take a while. I guess what you could do is sort of narrow that down, whereas instead of saying delete all, insert everything, you do it in groups. So you iterate basically over the temporary table, you grab, let's say, 1,000 rows, and then you say, hey, in the target table, all rows with this deployment ID, remove them. With these deployment IDs, remove them, insert, etc. It still means temporarily some of the data is not there, but it's going to be much shorter. Issue there still that could be annoying. If there's a system getting this data, it might see, hey, there is no data. And then, seconds later, like, oh, hey, now the data is there. The table swapping approach doesn't have that problem. Assuming you have, exact schema, etc. You start a transaction, you just rename them, and you're done. That's a very cheap operation. Issue there being is if you copy the table or you set it up, you also have to probably fix the names of all the indexes, sequences, etc. That is a little annoying. I don't remember if renaming a table also renames sequences and indexes. I don't think so.
Yeah, but then we still have the original problem of trying to figure out how to deal with an in-place update, which is the
so we use your approach, right? So we create a temporary table. We fill it up with all the appropriate data, etc. Then at some point we determine, hey, we're ready to swap. We start a transaction. We basically lock both tables. Then I guess we have to do one final check to make sure that any missing data is in this temporary table. We swap the names, commit, and then we delete the entire table that we have now, basically, in favor of this new quote-unquote temporary table. That particular approach means, one, the table is compact, because we insert all this new data, so it might actually save some space. Benefit there also that the process of swapping is largely dominated by how long it takes to figure out, hey, do we have any remaining data that we need to take care of? From a coding perspective, mostly the annoying part is going to be fixing all the index names, sequence names, etc., so that they are the way Rails expects them to be. And I think PostgreSQL has a way where you can say create table like this thing, and it will copy over indexes everything. It will just give them funny names, I think. But then you can basically just do a loop where you say, oh, all these things, rename them to that. I think that is probably the least annoying approach. It seems to certainly be easier than the CTID approach.
But will this copy also data, structure and data?
You can have it do both. I think you can just have create table with just a schema. I think you can also have it. Well, so there's two approaches. You can do create table as, I think is the syntax. And you can do something like create table and then feed it a select statement. It will fill it up with data.
Right. This you can do this, right?
But not the for keys and all that stuff. But you can do that a two-step approach. You basically copy the table with all the structures, etc., and then you just do a select into to copy over the data.
Yeah, but this is what what I'm doing with my merge request. The only difference is that instead of renaming, I just fill it. I copy back again and drop it, right? So this is because your point is to avoid the final copy back operation. Okay, so you just create the new one, put data in, and then you swap.
Yeah, basically.
Okay, got it.
And I think let me see. So we swap the tables. Yeah, I think technically you can take an existing index, for example, and change what table it points to, but then you have to start messing, I think, with PostgreSQL, the catalog internals. So it's probably just easier to recreate the index with like a different name and then rename all of them. Because let me see, because renaming indexes and everything that's instantaneously, you need a lock on the table, but so you just do alter table and rename all of them, commit. Should be fairly quick. But it is something we have to test with data. We probably have to copy the what's the best way of testing? I think what you could do is best way of testing is to create a copy of that table on production with just a schema and then measure how long it takes to fill it up. You could speed that up by basically creating a table but without indexes, filling it up, and then creating all the indexes. Because that way you only need to index once and not for every row that you insert.
Yeah, but then I have to take care of uniqueness by myself.
Yeah, and that's an annoying thing. And I admittedly, I think we've had some case in the past where we looked into that. I think it was when we migrated the events table. And I think the approach, it makes a difference depending on the index types, especially I have trigram indexes. They take a long time to update. But for most regular B-tree indexes, I haven't really seen a case where it made a huge difference. Or at least where it made such a difference that the amount of effort you have to go through to make it work was actually worth it. Yeah, so in this case, I think we could do a look at the swapping approach. There's a SQL query approach where you can just do, create table as, give the table name, and then with indexes, constraints, whatever, you'll do the whole thing. And then I think we can do it in such a way that the schema file remains unchanged. And that we can probably do this in a reasonable amount of time without, services temporarily not having access to their data, etc. Yeah, so that's, I guess, my suggestion.
Yeah,
I could
it's a lot
probably
to
also
digest.
Yeah, I can take a look at it as well tomorrow, see if I can come up with at least, hey, these are the queries we need to run, that sort of thing. And let me write that down. Oops.
Yeah, I will. I think that tomorrow I will give a chance also to take a look at paginating over some other resources, because basically this table is linking 3 resources. So if I can paginate over, let's say, environment, and then I can use the CTID in the where to issue the update, maybe we can update this in place.
Right.
It's just a matter of dealing with duplicates, but
yeah,
maybe
I think for
it's easier to understand, even if it may ends up looping over a bigger selection of data, because environments, I think we have more environments than the deployment row.
Yeah, I think you could probably paginate by deployment ID, since it is, I mean, there are duplicates, but probably not that many. Sorry, am I saying it correctly? Yeah, there are multiple rows with the same deployment ID, but if you basically sort them ascending, you can do where deployment ID is greater than. That might be even easier. Not entirely sure. But I'll tomorrow take a look at the sort of table swapping approach, see if that even makes any sense. All right, let me stop the recording.